Hello students. So today we're gonna study carboxylic acid. So carboxylic acid is one of the most important chapters of organic chemistry. So let's see. So first is our preparation reaction as usual. So let's see the preparation reactions. So first is, if we want to derive carboxylic acid from our what? Alkane. Okay. So if we want to derive carboxylic acid from alkane, so let's see what happens. That is, let us take this. Okay. Alkane. First is, if we want to derive carboxylic acid from any alkyl group, that is R group. Okay. So let us see an example, that is, let us take toluene as an example. Okay, because toluene has the CH3 group on it. So we're gonna add alkaline KMNO4. Okay, so it will just convert this CH3 group into COOH. Now, what happens if we have this group, that is here CH3, it is here also CH3, and it is here C2H5. Then also, if we just give it alkaline KMNO4, this total group, okay, total group will be converted into COOH, that is our benzoic acid. Now let us see. If we want to derive acid from trihalo compounds, so let us write it from trihalo compounds. So the trihalo compound, let us see, take this. So we just have to react it with NaOH solution. Okay, in presence of H2, that means aqueous NaOH solution. So it will just give us RCOOH. Now, third is from alkyl cyanide. From alkyl cyanide. That is, let us take RCNN. Now we can also take this also. It will also give us the same product, that is our acid. So this CN group is totally converted into COOH. There is no decrease of carbon, no increase of carbon. The carbon number will be same, but the CN group will be converted to COOH. And here is also same thing happening. That is, it will be COOH. Okay. Now let us see the. So in the fourth case, if we want to derive it from amides. Okay. So let us see what will be the reagent. The reagent will be HNO2 into NaNO2 solution plus HC. So it will just give us RCOOH. That means this CONH2 group is being converted into COOH. So you have to don't look at anything. If the C double bond NH2 group is present and HNO2 N plus NaNO2 plus HCl is given, just convert that CONH2 group into COOH. Okay. So you don't have to do any other things. Now let us see some properties of carboxylic acid. Okay. properties of carboxylic acid. Now let us see the acidic strength of different carboxylic acid first. That is acidic strength according to the group present in it. So let us take this. Let us take it as 1. Here we are comparing acidic strength. So let us take it to 1. And we are also taking this group. So it will be 2. Next is this group, that is NO2. So let us take it as 3. And we also are taking this group. Okay. That is our CH3 again. But it is in para position now. So let us take it as 4. So what will be the acidity order? The acidity order will be like this. COOH CH3. First, let me write it. Then I am gonna explain it. Why it is being like this. Then it will be COOH NO2. Then it is COOH. Then it will be COOH CH3. So why is it happening? That is why, because most of you know that NO2 is minus I group, so it will have more acidity than the normal COOH group here. Okay, so that is why it is written greater than this, and it has plus I group CH3, so it will have less acidity than the normal COOH. Okay, so it is written like this. But what happens in this case? It is also plus I group CH3, but it is greater than this NO2. Why it is happening? Because there is a effect which is acting here. That is called our ortho effect. Okay. So what is happening in the ortho effect? That is, if any group, that is can be plus I, can be minus I, if it is present in this ortho position of this carboxylic acid, or here we can say the benzylic acid, what happens? Then the carboxyl group gets out of the plane. Okay, due to the steric hindrance, and the resonance will stop working. And when the resonance stops working, the benzoate ion has the maximum stability, because it has no plus I or minus I affecting group, and its acidic strength will be our maximum. Okay, so that is why this has more acidity than these 3 of the acids. So let us see some general reactions of the carboxylic acid. Reaction with PCl5. So let us see, if we react it with PCl5 and give it some heat, then what happens? This OH gets replaced by Cl, and the final product will come like this. Okay, so it forms a acid halide. So next, let's see reaction with NH3. That is C double bond OH plus NH3 is given. It will form compound like this. That is a acid amide, right? And here also, if we take this, it will give us this, right? So it is the reaction with ammonia. Now let us see formation of anhydride. Anhydride. So that is, if we take CH3COOH and give it some P2O5, okay, so what will happen? Acid anhydride will be formed. Okay, it is also valid for benzylic acid, that is, give it P2O5, it will form this. Okay. Now let us see another reaction that we have already seen in our alcohol video, and that is our esterification reaction. So what is esterification reaction? That is, this group is called ester. Okay, this group will be called our ester group. Now let's see how it is found. That is, if the any carboxylic acid reacts with any alcohol, okay, so it is forming ester. So let us see the reactivity order of esterification reaction will be 1 degree greater than, and so the esterification reaction reactivity order of the alcohols will be 0 degree greater than our 1 degree greater than our 2 degree greater than 2 degree greater than our 3 degree. Okay, so let's see what happens, that if we take a carboxylic acid, it is COOH, and here we are taking a alcohol, that is CH3CH2, that is ethyl alcohol, and we are taking it isotope of oxygen, that is O18. Now what happens? This OH bond gets broken here, and this OH bond gets broken here. So this total CH3CH2O goes to this carbon and gets added with it. So it will be O18C2H5. That's how esterification reaction is formed. So what is Kimmich reaction? Kimmich reaction is if we want to convert carboxylic acid into alkylamine, then we use this Kimmich reaction, that is N3H, and we just give some concentrated H2SO4 and heat, and it will be converted into NH2 from the COOH group. So it is a C-1 reaction, because you can see here 1, 2, 2 carbon is present, but here as you can see that in place of this COOH, NH2 group is coming, so it is obviously a -1 reaction. Happens in Hofmann-Boehmite reaction. If we take a amide and want to convert it into alkylamine, so we use this Hofmann-Boehmite reaction, that is Br2 plus KOH or NaOH. We are writing it here KOH, so it will give us our NH2. Next is our Volhunt Zelezny reaction. We also call it HBZ reaction. Okay, so what will happen? This reaction to be happening, there should be one alpha H2 in adjacent to this COOH group. That means here it has 3 alpha H2. So the alpha H2s will be converted to bromine here. So 8P plus Br to the reagent it is. So it will be looking like this after the reaction. Okay, so that is what is HBZ reaction. Ascolt HR synthesis. So I am telling you this is a C+1 reaction. Okay, so what happens here? If we just react a normal carboxylic acid with you have to remember the reagents, because here it is many reagents are present. That is PCl5 heat, CH2N2 in ether, and also Hg2O, H2O, and also heat. That means PCl5 delta CH2N2 in ether, Hg2O, H2O, heat. So what happens? Another CH2 group is added in between this R and C double OH group. Okay, so CH2 group is added here. So that is why it is a C+1 reaction. Okay.